Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Matsidiso Kongwani. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Remember, grade 12, our WhatsApp number is 079 578 2908. I'm repeating again, 079 578 2908. You are more than welcome to send any clarity seeking questions to that particular number or any alternative solution that you like to share with us. Today we are looking at the trigonometry, of which is our paper 2 topic. And then this topic, out of your 150 marks, it is worth 50 plus minus 3 marks grade 12. That is a lot. So you need to give this particular topic an attention, undivided one. Okay, and then after the completion of today's lesson, you will be able to, number one, simplify trig expressions or equations by making use of your calculator. That means on those particular questions, you will be directly asked to substitute a certain value, and then you apply a calculator to find your trig expressions or equations. And then now you will be simplifying trig expressions and equation referring to special angles, and then this will be what? Without using a calculator. When you talk special angles, we are talking about 0, 30 degrees, 45, 60, 90, 180, and 360 degrees angles. We are excluding 270 because it's not part of our curriculum. And then you must be able to apply trig ratios in solving right angles triangle in 4 quadrants. That means you'll be given angles inside a right angle triangle, and then you must be able to find the sides and the unknowns using your trig ratios. And then you must be able to apply reduction formula. With reduction in technical mathematics, we only reduce around 180 plus minus theta, or the 360 plus minus theta. We are not using the 90 grade 12. We do not use 90 plus minus in technical mathematics. We do not use the 270 plus minus theta because we don't do co-functions like in mathematics. So in tech maths, we will only be considering 180 plus minus theta and 360 plus minus the theta. And then you must be able to solve trig equations, and then your trig equations will be solved where theta lies between 0 and 360. Basically, grade 12, you will be solving in all quadrants, 0 up to 360 degrees. And then you must be able to apply and prove trig identities. All your identities, remember, you'll find them at the back of your question paper. And then you must be able to solve a 2D and 3-dimensional problems. So that is your trigonometry. Basically, you will also add your trig functions out of that 50 marks that we are talking to. Okay. And then now, in all of our applications, where we are having a triangle of 90 degrees as indicated in yellow there, therefore you can apply the Pythagoras theorem to calculate your sides, your angles, and so forth, all right? For angles, you can apply sum of angles of a triangle, and then to find your sides, you can apply the Pythagoras theorem. What does this theorem state? It states that the c squared, why are they starting with c squared? A c squared is an hypotenuse side. That means it's a side that is opposite the 90 degrees angle. Hence, we are having c squared there, which is equal to the sum of the other two sides squared. Can you see that, grade 12? Always, please, to make your life easier, start with the hypotenuse side, which is the side opposite the 90 degrees. And then that will be c squared in this case, of which is equals to your a side squared plus your b side squared. And then now, out of that, you can say c is equal to the a squared. That means if this c loses an exponent 2, this side will gain a plus minus square root, but because we are talking to length, we will only consider the positive one. Okay, that is the first interpretation there. And then the second one is in a case where you want to maybe solve side A there. So in order to find A, let's look at the original there. Remember, we are having the C squared equal to A squared plus B squared. Let's say now we are looking for the value of A here. We must make A subject of the formula. Then we are going to transpose the B squared to the left-hand side. It will be C squared minus B squared equal to A squared. And the A loses an exponent, therefore you'll be left with A equal to this side will gain the square root. Remember, we are only considering the positive one. It will be C squared minus the B squared. Hence, we have C squared minus B squared there. Okay? And then lastly, the same applies to the B. We are taking the same original there. And then if you want to make B the subject of the formula, you are going to transpose the A squared to the left, and then it becomes minus A squared. And then you'll be left with the B squared. And the B squared loses an exponent too. Then you'll be left with B because we need B, not B squared. And then if this side loses an exponent, this will gain a plus minus square root of whatever you are having this side. But because it's a length, that is why you consider only the positive answer there. So hence we have this notation there where B is equal to the square root of C squared minus A squared. They are all informed by this original that came from Pythagoras theorem. Remember, you apply Pythagoras theorem only on a 90 degrees triangle, right angle triangle. You can't just apply in any triangle. And then now let's look at the trig ratios. Yes, we are taking Pythagoras theorem, but together with our trig ratios now. The original ratios is a sine, a cosine, and a tangent, grade 12. Right, and remember now I've indicated that a side that is opposite the 90 degrees angle, that will be your hypotenuse side. And then now the side that is opposite your angle in reference to theta now, angle A, that means this side, it will be the opposite side to your theta angle there. As you can see, it's opposite. And then this one will be an adjacent side. Opposite, adjacent. The one opposite to 90 degrees is your hypotenuse side. And then now we have these abbreviations here that we are using to assist us to remember the ratios for our trig ratios now. And we have this word SOHCAHTOA that we have created to remind us. We have a SOHCAHTOA. And then this S stands for sine theta, or any angle that we are referring. It can be theta, alpha, beta, or it can be angle A. Depends on what you have indicated on that particular angle. And then now the sine of theta is equal to opposite. Can you see this O stands for opposite, and the H here is for the hypotenuse. So it reminds us that when we are looking at the sine of theta, we are looking at the opposite over hypotenuse. Now in this case, now when I'm standing at theta and then I'm looking at the opposite side, that is my BC side. And then over the hypotenuse side, of which is the AB side. Hence we end up with the ratio sine theta is equal to BC over AC. Right, and then now when you look at the cos, the same now, SOHCAH, we are now using CAH. And then with the cos, with the CAH, C stands for cos theta, or a reference angle that we are referring to. And then the A here is equal to adjacent over H for hypotenuse side. Adjacent over hypotenuse. Now we go to the theta angle in reference to theta. What is the adjacent side? The adjacent side is AC there. So that means that is why we are having AC on the numerator there. And then now over the denominator hypotenuse, our hypotenuse side is AB. Hence we have AC over AB there. And then when coming to tangent, TOA Tau RT is for your trig ratio tangent of theta, and then O is for the opposite side over the adjacent side. And then our opposite side here is BC, and the adjacent side is AC. So the ratio for tan theta will be BC over AC for this particular triangle. So that is how you identify your ratios, grade 12. This only again applies in a 90 degrees triangle. You can't use trig ratios where you do not have a 90-degree triangle. Okay, and then now we also need the reduction formula. We are collecting all the tools that we need before we start answering questions on trigonometry. So you need your reduction now. Reduction helps us to reduce angles to be less than 90 degrees. And then in this case now, we are going to consider only reduction of 180 and 360 grade 12. We do not use 90 and 270 on reduction in technical mathematics. So now in quadrant 2, remember when we are in this quadrant 2, we are counting our quadrants. This is our first quadrant, but we count them anti-clockwise. Remember, clockwise we go this way according to the clock, but now we are counting this anti-clockwise now. So now this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So now when we are in quadrant 2, we are having reduction 180 minus, because now this is less than 180. When I'm in this quadrant, I am less than 180. So hence we end up with 180 minus theta to that quadrant. But immediately when I pass this 180 line, I move into the third quadrant. I will be more than 180. That means we must add something into 180 because we have passed that level of 180. So when we are in quadrant 3, is 180 plus, hence we have that reduction there, 180 plus. And then in quadrant 4, we do not consider 270. Remember, grade 12, we will be using 360. But when we are in this quadrant 4, we have not yet reached the 360 line. We are less than that. That is why we say 360 minus. Hence, we end up with that ratio 360 minus theta there. And then now, when you revolve for the second time, then you are having a 360 plus. We'll be having an angle that is more than 360 degrees. It's because you are now taking the second revolution. Remember, when you revolve, you start from 0, 90, 180, 270. Up to here, we are at 360. But the minute you start revolving again, that means we have added on top of 360 now. We have something more than 360 degrees. And then now we have this abbreviation here, cast. And you start that in quadrant 4. So you have that cast. This cast is assisting us to remind us which ratios are positive in each quadrant now after your reduction. You can see that in quadrant 4, C, this C is in quadrant 4, fourth quadrant. And then it's representing that cos is positive in that particular quadrant. It's always positive. But if you are in quadrant 4, it happens that you end up with a sign of theta and so forth. That sign will be negative. And the tangent is also negative in this quadrant. Okay. And then now let's move to cast A now from our cast. That is quadrant 1. In quadrant 1, all ratios are positive. All ratios are positive. You have sine, it will be positive. Sine. Tan will be positive. And the cos will be positive. All our ratio, even its reciprocals, will be positive in that particular quadrant. And then now quadrant 2, that means we are looking at the S now. This represents a sign, not a sin, grade 12, but it's a sign. Remember, it is abbreviated from sign, the full one is sign. So now we abbreviated it as SIN, so it's a sign, not the sin, okay? So it's sign that is positive. So if I can have a tangent and a cos in this particular quadrant. Therefore, this 2 will be negative on that quadrant. That means sine is in charge. In quadrant 3, tangent is the one that is in charge. If I can have a cos here and the sine here, they will both be negative in quadrant 3. So now when we reduce angle, we also check in which quadrant is that particular ratio, and then to check whether the sign is positive or negative. You'll see that as we do our reduction activity there. So, and then now we have our special angles. I've talked to this earlier on. We are talking to angles that fall on the line. We have 0, 90, 180, 270, and 360 there. So now we regard that as special. As we can see, we have 0, we have 60, we have 90, we have 180, we have 260 there. 270. 360 and 0, they play the same role here. That means 0 also represents the 360 degrees, is the same, because we talk of the same line there. Okay, now we, on top of the ones on the lines, on the Cartesian plane, we are adding the 30 degrees, the 45, and the 60. Those 3 are also special angles. And then this table will now assist you, but don't stress about it that much. Your calculator can also give your special angles grade 12. So that is the sum with all the reciprocal. At some point, these are not defined. As you can see there, the chord of theta of 0 is undefined. The cosec of 0 is undefined. And then the tangent of 90 is undefined. The sec of 90 is undefined. Can you see that? Okay, we'll come to that later on. And then if you are having the chord of 180 is not defined, a cosec of 180 is undefined. And then the tangent of 270 degrees is not defined. And then now the sec of 270 is also undefined. When you do with your calculator, it will show an error to show that that is not defined. Okay. And then now we have identities that we apply as we are proving our left-hand side equal to right-hand side, where you need to apply these identities, or in cases where you have to simplify your expressions now, and then somewhere, somehow, you will be needed to apply these trig identities. So we have 3 classes of identities. The first one is a square identity. The second one is a reciprocal identities. And the third one, we are having the quotient identities. So with the square identities, you cannot apply these identities unless you see a square. As you can see, all of them are having squares there. Okay, we know the 1 squared is still 1, 1 squared is still 1. Basically, that means everything must be in terms of squares in order to apply square identities. So now the first identity here, we are having a sine squared plus cos squared equals to 1. That means you can remove wherever you're having your sine squared plus cos squared and substitute that with the 1 because they are exactly equal. You can play around with this one, maybe leave a sine squared this side and take a cos squared to the right hand side. It will be 1 minus the cos squared theta. And you see that it allows you, where you're having a sine squared theta, you can remove and write 1 minus cos squared. Or where you have 1 minus cos squared, you can remove and write sine squared theta. It depends on the need of your expression or your equation that you are solving. Or you can decide to leave cos squared theta. So if you take sine to that side, it will be 1 minus the sine squared theta. So all of this, they come from this original here. Okay, you can play around, more than allowed to play around with that. The same applies with this one. It is 1 plus tan squared theta. It must have a square, of which you can remove 1 plus tan squared theta and substitute that with the sec squared theta. Or vice versa, you can remove the sec squared theta and substitute that with 1 plus the tan squared theta. You can play around with it, grade 12. You can take a sec to the right, a tan to the right. It's up to you. how can you play around with these ratios now? By transposing to switch what you need according to the need of your expression. Lastly, on the square identities, we are having 1 plus cot square theta is equal to the cosec square theta there. Same, you can play around with that also. Second bracket, you are having reciprocal identities. With the reciprocal identities now, a tangent goes with the cot, the cosec goes with sine, and the sec goes with a cos there. That means now when I'm having a cot, I can write it as 1 over tan. When I have a cosec, I can write it as 1 over sine. When I'm having a sec, I can write it as 1 over cos. The same applies where I have a tangent, I can write it as 1 over cot. When I have a sine theta, I can write it as 1 over cosec theta. You can play around with that, grade 12. I can have a cos theta written as 1 over sec theta there. And then when coming to the quadrant, the cast diagram that I've explained earlier on, in terms of being positive or negative in a certain quadrant, in quadrant 2, where we have a sign being positive, also is reciprocal, cosec will be positive in that quadrant. The same applies with tangent. In quadrant 3, tan is positive. The same applies with cot. When cot is in that quadrant 3, it will also be positive. Same with the cos. In quadrant 4, cos is positive. That means sec will also be positive in that particular quadrant. That is what we mean about the reciprocals. And then in the case where you are using a calculator, remember our calculator is having only a sine, a cos, and a tangent. If now your problem is given in terms of a cot, a cosec, and a sec, that means you need to change to its reciprocal to be able to use your calculator, because we don't have these reciprocals on our calculators. Okay, and then now we have lastly the quotient identities. With the quotient identities now, where we have tan, we can write tan as sine over cos, and then if we take its inverse cot, we can write as cos over sine for its reciprocal. Okay, and then now with identities again, reciprocal identities, grade 12. If I'm having a tangent, remember now a tangent, do you still remember SOHCAHTOA? With SOHCAHTOA, if I'm having a sine, sine is y over r, opposite over hypotenuse, y over r. And then if you look at sine here, sine and a reciprocal of sine is a cosec. So if I'm having a sine of theta and writing it as opposite over hypotenuse, that means the reciprocal of this, of which is cosec theta, it will be h over opposite hypotenuse. That means the inverse of that one. Okay, so that is what we do with all the reciprocal. If it's a tangent, opposite over adjacent. When it's a cot, it will be adjacent over opposite. So we swap around the position of the hypotenuse of the denominator and the numerators. So that is basically how you apply those reciprocal. And then now we have degrees and radians. In some cases, our angles will be given in radians. You must be able, grade 12, to predict that. I have derived this smaller circle here, of which will assist you. Remember, basically, we are talking to 0 degrees, of which is our 360 degrees, of we have 2 pi. But originally, we'll be mostly talking to 180. Remember, when referring to radians. So our 108 is the same as the pi there, okay, or 1 radian there. So now half of 180, remember, is 90 degrees. It will also be half radian there. The same applies that when you go decide now 180 to 360 degrees, remember, its time is 2. That is why also your radian will be 2 radian there. Same applies and so forth, grade 12. So this basically will assist you. If you have 180 and then you want that, you know that you divide this 180 by 6. Hence, you end up with the 30. The same applies. This radian will be radian over 6 there. Okay. And then now let's say your angle is given in degrees. They have given you a 60 degrees angle, okay? And then you need to convert this into radians now. So now this is telling us now degrees to radians, changing degrees to radians. You must multiply your degrees by pi over 180, a radian over 180. And therefore 60 goes once there, 6, 12, 18, it goes 3 times into 80 there. Can you see now you are left with a radian over 3 there? Hence, we are having 60 is equal to radian over 3. So that is how you change that. Great jobs. Lastly, now, let's say you are reversing a radian to a degree. Now, if I am having a 2 pi or 2 radians, I want to change this to degrees. The method is saying multiply by 180 over a radian. That will be my multiply by 180 degrees over a radian. So the radian will cancel radian. You have 2 times 180, of which is 360 degrees. Can you see, grade 12, that is true. 2 radians is equal to 360. So this explanation will assist you in terms of changing that in future also for CMM, that is circles, angles, and angular movement topics. It's working mostly with radians there, and then some angles will be given in degrees. This will assist you, grade 12, to change them to radians. And then we have sine rule, cosine rule, and the area rule, of which we apply with 2D and 3-dimensional problems. With the sine rule now, you will be given a triangle like that one. A side that is opposite angle A, it will be side A, angle B, side angle, the side will be B, and then side opposite angle C will be side C. As you can see, angles are indicated by capital letters, the sides are using the small letters there. So now this rule says that if I'm having a sine of A over A, its side, it will be equal to the sine of B over the side B, equal to the sine of C over side C. So A is B and C, capital letters, are indicating the angles, whereas the small letters are indicating the sides. So grade 12, we can be given to, or if we can be given an angle B with the side A, you will be able to find angle A using these 2 ratios there. That is the sine rule. And the cosine rule now, in order to apply cosine rule, we are still talking to triangle ABC. I have already indicated that if you are having angle A, a side opposite angle A will be side A with small letters. So the cosine rule indicates that if you want to calculate side A, then that will be A squared equal to the sum of the 2 sides B and C squared minus 2BC. Still on the same side, and then cos of an angle that of a side that you are calculating. If you are calculating a side A, this will be angle A. If you are calculating side B, this will be cos of angle B. Calculating side C, this will be angle of C. And then now, if you calculate B, that means you'll be adding the other 2 sides. If you calculate in C, you'll be adding the other 2 sides, the square of the other 2 sides. Okay, grade 12. And then if it's AB here, this must also take AB. Remember, you'll find this at the back of your question paper. And the area rule now, with the area rule of triangle ABC, area of triangle ABC, you must be given 2 sides and an included angle. Included angle is an angle between the 2 sides given. So for example, if you want to apply half AB, AB is these 2 sides. So that means I must be given this angle here. As you can see, it's an angle between those 2 sides given to me. It must be an included angle, an angle between the 2 sides that you are having. So if I am given B and C now, given B and C, my included angle must be this one. I must have that included angle. And then if I'm using A and C, That means B angle must be given to me in order to be able to calculate the area of that particular triangle. That is the area rule. Yes, grade 12. Can we now start with the activities? Now the first activity is the method where you are using a calculator. That will be your first question on your question paper when you start your trigonometry. And then now in this case, they say that you are given angle X equal to 152.4 degrees, and then you are given angle Y is equal to 24.8 degrees. And they say determine the following now. 1.1, we have to determine the sign of X minus Y. That means we are given the value of Y and X there, we can just substitute into the given there. So that is the sign of X is 152.4 degrees minus Y 24.8 degrees then. And then into your calculator, grade 12, so what is inside the brackets? Now you are subtracting the 2. You'll be left with 127.6 there. And then you put everything into your calculator, grade 12, and then sign of 127.6 is giving us 0.79. That is the answer simplified of sine X minus Y, according to the given values there. 1.2, we are given 1/2 sec of X over 2 plus 80 degrees. And then this is worth 2 marks. Remember now, because we are using a calculator, our calculator does not have the sec button. All calculators do not have the sec button. So now we need to write this in its reciprocal form. Do you still remember grade 12? It's cast diagram. And then in quadrant 2, we have sine and cosec. The longest one is in quadrant 2, it goes with the sine. And then the cot goes with the tangent, cotangent goes with tangent. And then the cos goes with the sec. Okay, and then now that means sec, we can identify this is the reciprocal of cos. Happy with that one? Okay, we know what to do now. Let's start by substituting first. We have 1/2. We still keep the sec because we are substituting now. X is how much? 152.4 degrees all over 2 plus 80 degrees. We are busy simplifying the brackets, grade 12. We'll leave the sec for now. We'll deal with it later on. And then now this will be 156.2 if you divide and add the bracket there. And then now we have now simplified the bracket. We can now look at the reciprocal of this will be 1/2. And the sec is 1/cos. Its reciprocal is 1/cos. Our angle is 156.2. And then now into our calculator, straight to the answer. The answer is minus 0.55. When you say using a calculator, that means you are allowed to put in the values and put into your calculator and get your answer. No penalty, grade 12. And then now let's allocate the marks now. We said 2 marks for the first one. It will be first mark for the substitution and the second mark for the final answer. So you have 2 marks there. And also for the second 1.2, it's 1 for the substitution and 1 for the answer. I think this must worth 3 marks actually, grade 12, because now you need also to indicate that sec is 1/cos there. So this basically must worth 3 marks to be fair enough. Okay, and then now the next activity there, we are still looking at the substitution. Let's see, grade 12, I'm giving you 3 minutes to do that activity 2.1 and 2.2, and then we are given pi there, of which it needs to be changed, a radian to be changed to degrees. I have already shown you how to do that. And then please, you have your 3 minutes to do this activity. Your 3 minutes starts now. Okay, grade 12, let's see how far did you go with this activity. Remember to send your clarity seeking questions to our WhatsApp number 079 578 2908. Right. And then in this case, we are given angle P is equal to 2/7 radians. And then angle Q is given in degrees, 37 degrees. So the first question there states that convert the 2/7 radian into a degree. Okay, do you still remember the method I've indicated earlier on? We are going to say 2/7, this is radian. You multiply by what? 180 degrees over a radian. Can you see now? It must be below so that it can cancel that numerator one. And then now our answer here into your calculator, grade 12, this must give us 51,42. And then this is now in degrees. Okay. That is the 2.1. So it will be 1 mark for the answer there, not for the method, because you can just, some learners can just go through straight to the answer without showing the simplification using through the calculator method. And then now 2.2, determine the value of cosec P minus cos Q. Remember now we are substituting because we are given the values of P and Q now. And we have just calculated angle P in degrees. So now cosec P, that is the cosec, we are now substituting grade 12. What is P now? It was 2/7 radians, of which is equals to 51,42 degrees, minus the cos of Q. What is Q? 37 degrees. And then remember your calculator, you do not have a cosec button because it's a reciprocal. So we need to take this back to its reciprocal, of which is 1 over the sine. Sine of what? 51,42, of which is our angle there. Minus the cos of 37 degrees. So 1 over sine 51,42 minus the cos of 37 is giving us 0,48 as our answer there. The mark allocation is 2 marks. 1 mark, I also think this is unfair. It must worth 3 marks. 1 mark is for substitution, yes. The second mark must be for being able to change a cosec into its reciprocal. And the final answer for the last mark for the final answer. So now, fair enough, this problem is worth 3 marks, grade 12. Moving on, I hope you got that 4 marks. And then now, the next subtopic, now we are done with using a calculator. We are moving on to using a diagram or using sketches. And then now with using sketches, you will be given a trig ratio, and then you will be given a restriction, of which is restricting the quadrant, right? And then now in this case, we are given a ratio there. We have it at sine beta is equal to -4/5. And then we are given a restriction that it must lie between 90 and 270. Where is 90 and 270, grade 12? Which quadrants are those? That is quadrant 2, 3, 4. For example, let's say we are having our Cartesian plane is 0, 90, 180, 270, and 360 there. So when we revolve from 90, we revolve from this line here, 90 degrees, 180, 270. Can you see we are talking quadrant 2 and 3 only? We can't go into this quadrant because of this restriction here. It's only quadrant 2 and 3. Now, let's see now. We are given a sine beta, and then according to SOHCAHTOA, what is sine? Sine is opposite over hypotenuse, of which opposite is your y side and the hypotenuse is the r side. So in this case, that means we are given the y and the r. We are short of x in order to have all the ratios now, because when you talk cos need x there, x over r. Tangent also need y and x there. Can you see that? in order to answer all your trig ratios. If you can have your y value, your r value, and the x value, then you can answer any trig ratio, because sine is y over r, cos is x over r, tangent is y over x. Also, it's reciprocal. Remember, it will be swapping the same values around there. So now, let's see, what do we have? We have y and r, we need the value of x. You can't go and find x without indicating the correct quadrant, because this type of problem is where you are using sketches to solve. So you need to identify now, grade 12. Can you see I'm not answering the question yet? I'm identifying the quadrant. Where does this sign lie? So it says sign is negative there. In which quadrant is sign negative? Sign is negative in quadrant 3 and 4, because in quadrant 2 sign is positive according to the CAS diagram. In quadrant 1 all the ratios are positive. So quadrant 3 and 4, those are the quadrants. And then now remember, now restriction says rotate only from 90 to 270. Can you see now, grade 12, in which quadrant do you have your tick and your circle? That is quadrant 3. So this sign lies in this particular quadrant. Our beta angle now is from here to there. That is our beta angle. All right. And then now we can put in the values now. We are having the y and the r. R is always positive because it's the hypotenuse side. That means this negative is for the y minus 4. Okay? So happy now, we know the quadrant is in quadrant 3. And then the triangle that we are having there is of a 90 degrees triangle. If you have a 90 degrees triangle, that means you can now apply your Pythagoras to find the unknown. What is our unknown is the value of x, and you can see according to the diagram, this x value must be negative. Can we start now calculating the x? Yes, we can use Pythagoras. In using sketches, we always rely on Pythagoras to find the unknowns. So Pythagoras says that the r squared, of which is the hypotenuse, is equal to the x squared plus the y squared. And then what is our r in this case? R is 5, of which is squared. The x is the one that we are looking for, and the y value is a minus 4, of which is squared there. What is 5 squared? 5 squared is 25. And then we have x squared plus the minus 4 squared is 16, right? And then we are going to transpose this 16 into the left-hand side there. Then we'll end up with 25 minus 16 equal to the x squared. 25 minus 16 is equal to what, grade 12? That is equals to 9 x squared, but we are looking for the x, not x squared. Therefore, x will be equal to plus minus the square root of 9, of which is x plus minus 3. But now, if you look at this diagram, it is telling you that no, you must take only what? The x that is negative. Although this is giving us two solutions, but we need to finalize now that our x value will be of a negative sign. So x will be negative 3. I am now clustering my information. Now I'm having a y value which is minus 4 from the given there. I'm having the r value which is equals to 5. This information I can only use if my angle is beta. Okay, now grade 12, everything is clear. I have all the values. I know that I can use this only if I have beta. It's only then that I can answer the problems. The first one is saying find cosec beta now. And then remember, a cosec is an inverse of what? Of a sine. And then if sine is minus 4 over 5, that means this one will be minus 5 over 4, of which is taking the reciprocal of that one. That is why it's worth 1 mark here, because it is the reciprocal of the given one. Right. Okay, and then now let's look at 1.2 now. With 1.2 now, we need to identify a tangent. According to SOHCAHTOA, tangent is y over x plus a cos is x over r. We can now substitute from the table there. y is minus 4, and the x is minus 3, plus the x is minus 3 over the r, which is 5. And then grade 12, you can have a simplified negative by negative, it's a positive 4 over 3, plus minus 3 over 5, a positive by negative, it's a negative 3 over 5 there. Okay, and then now when you look at the LCM of the two, it will be 15, and then 3 into 15 is 5 times is 4, 5, 10, 15, 20, that will be 20, minus, and then 5 into 15 is 5, 10, 15, that is 3 times, and then 3 times 3 on top there, that is 9. So our final answer will be 20 minus 9, which is 11 over 15. I have solved this problem without using a calculator, okay, as it is indicated there, without using a calculator. So now the 5 marks for this one, grade 12, it will cater for the Pythagoras that we have used to find the value of x. That means for substitution into Pythagoras, for giving us the correct value of which is minus 3. That is your second mark. The third mark will be for substitution for tan and cos. And then the fourth mark is for simplifying this, and the last one for the answer. So that means this is worth 5 marks. Okay, now move on to the next activity. In the diagram, in this case, the diagram is given to you. On the previous activity, we identified the diagram by looking at the ratio and the restriction. But fortunate enough for this one, the diagram is given to you. And then in the diagram, they say OA is 3 units. That is 3 here, if it is not visible enough. And then the A is minus square root 5, coordinating with the K, that is point A there. And then now it's in the Cartesian plane. The angle of inclination of OA with respect to the positive x-axis is theta. That is from here to there, positive axis. Our angle here is theta. And then they say determine without the use of a calculator the numerical value of K, and then 2.2, you have to simplify that expression that is given to you. Remember now, it's very important that you must have a diagram. Do you have a diagram? Yes. In the diagram, we have the value of x there, and then the value of y is unknown. It's a k there. And then we have the r, which is a 3 there. Okay, can you see grade 12? We have an x, we have an r, we need the value of y, of which is k. Hence, the question says, determine the numerical value of k in 2.1. So to do that, we are also relying on Pythagoras, because we know that if we close this triangle, it will form a triangle of 90 degrees. Pythagoras says what? The hypotenuse side is equal to the sum of the square of the other two sides, of which is x squared plus the y squared. What is the r value? R is 3 there, that will be 3 squared, equals to the x is minus square root of 5 squared, the y is k squared. 3 squared is 9, a negative by negative is a positive, and then these two will cancel the square root sign. You are left with 5 there, plus the k squared. Transpose 5 to the left, that will be 9 minus 5, of which it's a 4, k squared. And then now k loses an exponent, you gain plus minus the square root of 4. Then we end up with k being plus minus the 2 there. But according to the diagram, can you see that k, the y value, our y values this side, they are positive. So we are looking for the y value that is positive. Therefore, you need to finalize grade 12 and tell us that the k value is a positive 2. Since you have plus minus there, the final one will be 2. So our coordinates here for A, then it will be the minus square root of 5 coordinating with a 2 there. That is our x and y values. So now we can have a table of clustering somewhere there if you want to, of which is telling you the x value is minus square root 5, the y value is 2 as calculated there from k, and the R value is equals to 3. But this will only work if your angle is theta. Now we move to 2.2, the grade 12s. With the 2.2, we are given the square root of 5 cot theta plus 1. So now we have the square root of 5. What is cot? Remember, a cot is a reciprocal of a tangent. And remember, SOHCAHTOA, a tangent is y over x. So its reciprocal will be a what? An x over y. We swap them around. And then we have a plus 1 there. The minute you write cot in terms of x and y, you don't write a cot theta anymore. Right. And then we have the square root of 5 into the x value minus square root of 5 over y, which is 2 plus 1. And then now let's continue simplifying. Remember, they said without using a calculator. So it will be square root 5 multiplied by the square root of 5. Then it will give us the minus 5 over 2 plus 1. LCM 2. And then 2 into 2 goes once. 1 times minus 5 is minus 5. Plus 1 into 2. 2 times 1 is 2. So this is minus 5 plus 2, of which is minus 3 over 2. It's our answer there. And then now the mark allocation, let's start with the 2.1 is 3 marks. That will be 1 for substitution. And then number 2 for having plus minus as the answer. And then the last one for finalizing the K value, that it will be positive K. That is our 3 marks. The second 3 marks allocation, greater. That will be for substitution again, for simplifying, and then for the final answer then. That is our 3 marks for 2.2. All right, moving on to the next subtopic under trigonometry. We are now looking at the reduction formula. Remember, when you talk reduction formula, we are talking that CAS diagram. You cannot do your reduction without having this diagram, grade 12. And then remember, we only use the 360 degrees and the 180 degrees. Before 180 is 180 minus. After 180 is 180 plus. That means in quadrant 2 is 180 minus. In quadrant 3 is 180 plus. In quadrant 4 is 360 minus, because it's before you reach a 360 line. In quadrant 1 is 360 plus there. So these are the only reductions that we are relying on. Okay? Remember, CAS diagram is reminding us that cos is positive in here, and the tangent positive, and the sine positive. Other ratios, when they fall into that quadrant, they become negative. Let's see now. We have sine 180 plus a cot 360 minus a multiplied cos 2 radian. Can you see 2 radian there? Remember, radian is 180. 1 radian is 108. If it's 2 radians, that means it's 180 times 2, of which is 360. So that means here, grade 12, basically we are having 360 degrees minus a. So we are talking quadrant number 4. So if it is 2 radians, that means 2 radians, they fall into 360, the same value there, right? And then now we start reducing now. Okay, we have 180 sine of 180 plus theta. Where do we have 180 plus theta? That is in quadrant 3. Can you see? And then in quadrant 3, now you check sine. Is sine positive or negative? Sine is negative in that particular quadrant. Then you start by that negative. And then it's a sine. And then this 180 plus, we were just using to identify the quadrant. So our angle will remain minus sine A, because you have now checked the quadrant, reduced the angle into A. And then now we move to the second ratio. Multiply. Please avoid these dots, because if it's minus, you end up subtracting instead of multiplying. So use the normal multiplication sign and avoid the dots. So you have a cot of 360. I'm not writing anything. I go to the quadrant 360 minus. Which quadrant is that? That is quadrant 4. 360 minus. Cot, remember, is the reciprocal of tangent. Ne? That means if a chord is in this quadrant 4, it will be negative because it's only cos and sec that is positive. So chord in quadrant 4 is negative. Oh yes, then I start with that negative sign. I'm having minus chord of A reduced to A, and multiply again. I'm avoiding a dot. Remember, 2 radians is 360. That means 360 minus, I am still in quadrant 4. Is cos positive or negative in quadrant 4? Cos is positive in that quadrant. That means we leave this as being positive cos reduced to an A. And then now still in 360 minus A, we are still in quadrant 4. How is sine in that quadrant? Sine is negative in quadrant 4. That means now we will be having a plus, and then we put this in bracket, minus sine A. Why are we putting it in bracket? Is because it is squared. It means we are having 2 minus sine A's. We have tested 1 in 360 minus quadrant and found that a single sign is negative. But in this case, it's having exponent 2. That is why we are raising this to exponent 2. Let's simplify now. We are having, for this multiplication here, we have a negative times a negative will end up with a positive. So we can write sine A multiply. Remember, a chord is a reciprocal of a tangent. And what is tangent? Tangent Katoa. A tangent is opposite over adjacent. Or you can use the identity of a tangent. Remember, tangent is sine over cos, right? So in this case, if we have a chord, we can write as a reciprocal. It will be a cos of A over the sine of A for a chord A, right? Move on now, multiply by cos A, we leave this one, and then now we deal with the negative. 2 negatives will give us a positive, so we end up with plus sine squared A. But remember, you are multiplying here. What must rule? You start with multiplication before you go addition. So the sign on the numerator will cancel sign denominator. Remember, this is over 1. And then we'll be left with cos A multiply by cos A plus sine squared A. And the cos A times cos A is cos squared A plus sine squared A. Can you see that, grade 12? We have now created what? An identity. Remember, an identity, sine squared plus cos squared is equals to 1. The same applies if we have sine squared plus cos squared. Then our answer will just be a positive 1. And then now this problem with 7 marks, how do we allocate marks? Reduction formula is where we are collecting marks in trigonometry, because after reducing your angles, marks will be allocated for each ratio that is reduced correctly. So now we have reduced minus sine A correctly, that is your first mark. Reduced the chord correctly, that is your second mark. Reduce the 2 radian correctly, third mark. This one with the sign negative there, that will be your 4th mark. Only on that reduction step you have 4 marks, grade 12. And then now the 5th mark will go for showing that chord is cos over sine. That is your mark number 5. For simplifying this to cos squared plus sine squared, that is your 6th mark. The last one is for giving us that the sine squared plus cos squared is equals to 1. Then this is your 7 marks. Can you see? Your main 4 marks out of 7 comes from your reduction. You must ensure that you've reduced correctly into the correct quadrant that will give the correct sign of your ratio. Double check it, grade 12, before you finalize it. Okay. Let's look at this one now. We are still on reduction. Can you see now you have radians somewhere there? Remember, you must deal with the radians first. Ensure that your mind understands in which quadrant you are in. If it's 2 radians, remember it's 360. If it's a 1 radian, it's 180. That's the first thing you have to need to attend to, grade 12. Now we are clear. We know where we are now. We still need that cast diagram to assist us. You'll note it somewhere on your scrap book. Remember, cos is positive, all ratios are positive, sine is positive, tangent is positive there. And then if sine is positive, also cosec is positive there. If tan is positive, also cot is positive. If cos is positive, also sec is positive. That means other ratios in those quadrants are negative, right? Right, now we have sine of 360 minus. So 360 minus is indicating what, grade 12? A quadrant. Which quadrant is that one? Remember, we have 360 line there. That is minus below, positive on top. 180 degrees there below, it's a minus, it's a plus, and then this is less than. Okay, less than 180, greater than 180, less than 360, more than 360 on that side. So we are looking at 360 minus. 360 minus, can you see that? That is in quadrant number 4. Remember, that is quadrant 1, quadrant 2, quadrant 3, anti-clockwise, and quadrant 4. So 360 minus is in quadrant 4. Is sine negative or positive in that quadrant? Our sine ratio will be negative in that particular quadrant. Then we have reduced this to minus sine alpha. That is how you use reduction. A dot, we are going to apply multiplication. Right, we check the quadrant again. We have quadrant 180 minus theta there. Which quadrant is that one? Minus 180 minus theta, that is quadrant number 2. In quadrant number 2, is tan negative or positive? Tan is negative in that particular quadrant. So we end up with tan alpha reduced minus tan alpha reduced, negative tan alpha reduced. A dot multiplication sign. Again, we are checking 2 radian minus alpha, that is 360 minus. So we are still in quadrant 4, grade 12. And then quadrant 4 is cosec positive or negative. Remember, cosec is a reciprocal of sine. That means cosec is negative in that particular quadrant. Negative cosec alpha. Go to the denominator now. 360 plus, which quadrant is that? It's when you are revolving for the second time now, back to quadrant 1 again. In quadrant 1, all ratios are positive. That means cos is positive also there. Multiply. Cosec 180 minus, that is our quadrant 2. In quadrant 2, is cosec positive? Yes, because it is reciprocal of sine. If sine is positive, cosec will also be positive in that quadrant. Cosec alpha. Multiply. 180 minus, that is quadrant 2. Is tan positive or negative? No, tan is negative. That is why I close the bracket, because why? This tan is squared. Can you see that? Yes, giving us the negative, but we need to square that to end up with the positive. That means all your ratios, as long as they are squared, you must know, even if they take a negative, they will end up being a positive, grade 12. Right, let's try to simplify now. We are having minus sine alpha on top, multiply by minus. Do you still remember a tangent is identity sine over cos? Multiply. A cosec, remember, is the reciprocal of sine, so it will be 1 over sine alpha. That is our numerators, division line for everything. On the denominator, we have cos alpha, multiply by cosec is the reciprocal of sine, it will be 1 over sine alpha. And then multiply by negative squared will be positive, a tangent is sine over cos. Positive 1, because 2 negatives, they will give us a positive. Let's look at the numerator first, grade 12. We are having a sign here. That sign will cancel a sign there. Okay, so on top there we are having a negative times a negative, or this is also negative here. So we have 3 negatives on top, of which will give us a negative answer. So a negative times a negative here will give us a positive. Okay, and then times a negative, it will be minus. And then on top we have sine multiplied by 1, of which is minus sine alpha. And then divided by cos alpha. That is our numerators. I'm bringing this division for denominator the side, not to have too many fractions there. And then the sign here is numerator for the denominator part. We'll cancel with that one. Okay, goes once. And then on top, when you look at the top there, we have cos 1 and 1 there. That means will be cos alpha. Divide by, it's 1 times cos, it's a cos of alpha. Then a cos into cos is 1. So grade 12, we are left with minus sine over cos, of which is a tangent of alpha. Divide by 1 is the same thing. So our answer will be minus tan alpha. I hope we are still together on that one. Moving forward to the next question. All right. This is the subtopic for trigonometry. Now we are moving to subtopic identities. In this one, you are strictly required to apply your identities, grade 12. Okay, and then now let's rectify this. It's supposed to be a negative there, not a minus. It's not a plus, it's a negative. So it's cosec x minus cosec x dot, or multiply by sec x over sec x minus bracket tan squared x plus 1 equal to cot x. And then we are given that. And then we need to factorize first the sec x minus sec squared x. How do you do that? Can you see we have a common sec x there? We are going to take it out. Sec x as a common factor. The minute you remove this one, you'll be left with 1 minus, remember here you have 2 of them, and then if you take 1 as being common, you'll be left with another sec x there. So that is the factorization of that, hence it is only 1 mark. And then 1.2, they say hence prove their identity. Remember I said to you this is a minus, not a plus, right? And then now, can you see now you are applying the common factor method on both numerators and the 1.1 that was given to you? Okay, we can now, remember grade 12, when you are proving an identity, you concentrate on only one side. You can't take the whole thing and then prove. You need to show, when you prove, you show us that the answer for this left-hand side will be that one. That means the answer is given to you being cot x, okay? And then now, let's start now. We are given cosec x minus cosec x multiplied by sec x. On the denominator, we are given sec x minus, and if you look at 1 plus tan squared x, this is an square identity. Remember I explained earlier on the types of identities. This one falls on the square identity. So we can remove 1 plus tan squared x and write it as sec squared x there. And then grade 12, please indicate that you are using your left hand side in order to prove this. You leave the right hand side on your equation there. And then now from there, simplification, you can see you have a common factor on top of which is cosec x. I hope we are still together there. And then when I take cosec x out here, I'm left with 1. Minus take cosec x out, I'm left with sec x. And then on the denominator, I take out sec x because I can see it's common there. Sec x. From the first one, take out cos x, we are left with 1. And then here you are having 2 sec x, so it will be 1 minus sec x. Hence, they have asked you that question first. And as we have an hence indicated on 1.2, use. Hence means use, apply the previous answer to simplify this one. So now you can see that you have common brackets that you can cancel there or divide. So we are left with only cosec x over the sec of x. And then now we know that grade 12, the cosec is a reciprocal of a sine. So we are going to write it as 1 over sine x there. So divide, I'm shifting the sec x with the division on the right hand side. And the sec is the reciprocal of a cos. Therefore, we'll write it as 1 over cos x there. Continue, 1 over sine x. Then we change the division into what, grade 12? The multiplication sign. Therefore, it will be cos x over 1. Remember, the minute you change division to multiplication, the term that is following it must swap around to denominator and numerator. Then 1 times the cos x is cos x on top, and then below sine x multiplied by 1, it will be a sine x. Do you still remember? Cos over sine is a cot x. Therefore, your left-hand side is equal to the right-hand side. Exactly the same answer there. The answer was given to you already, grade 12. Okay. And then now move to question number 2. Complete the identity 1 minus sine squared. Do you still remember? We were playing around with the sine squared plus cos squared equal to 1. And then if you leave the cos squared, then you will end up with 1 minus sine squared. That is exactly what is happening here. It comes from what? The sine squared that you're having plus cos squared, original identity of equal to 1. So if it is 1 minus sine squared theta, that means they've taken this sine to this side. So you'll be left with what, grade 12? The cos squared theta. So this particular identity, then, it will be equal to what? The cos squared theta. So that is all we need there. Fill in the cos squared theta. Hence, it is only 1 mark. And then number 3, prove the identity that cosec x minus sine x is equal to cot x multiplied by cos x. Remember, now you have a left-hand side, you are proving that the left-hand side is equal to the right. You cannot take anything and transpose from left to right, because you need to prove what is on the left is equal to what is on the right-hand side, grade 12. So we are going to concentrate only on one side, of which is the left-hand side, and see, can we get that answer, because the answer is given to us there. Right, if you take the left-hand side now, this cosec, we are going to write it in its reciprocal form, of which is 1 over what, grade 12? That is the reciprocal of a sine, therefore it will be over sine x there, minus the sine x there. Remember, if there is no denominator, it is over 1. Continue now. We are subtracting 2 fractions. The method doesn't change in maths. As long as you are subtracting fractions, you look for the lowest common multiple or denominator, of which between sine x and 1, it will be a 1 sine x there. And then let's apply now. It's a sine x into sine x once, and then 1 times 1, it's 1 minus this negative in between there. And then 1 into sine x, it's a sine x. The sine x multiplied by sine x is a sine squared x. We are using your algebra method now of dealing with the LCM method. And then 1 minus sine squared, grade 12 is what? 1 minus is what we have calculated. This question was supposed to be a hence question because it is using the previous answer. So that is 1 minus sine squared. We said earlier on it's cos squared theta over the sine x. Okay, and then if it says cos squared theta, that means we are having 2 cos, not cos theta, cos x, sorry. Cos x multiplied by the cos x is giving us cos squared x. And then on the denominator, we have a sine x. So remember, cos over sine identity is a what? It's a cot x. So these two give us cot x, and then we multiply by cos x. Can you see, grade 12? Your left-hand side is equal to your right-hand side. Please write this conclusion after solving your problem. We solve only using one side, not both of them. Okay. Move to the next subtopic. We are talking to trig equation. Can you see, grade 12? It's a lot of work. It's a lot of work under trigonometry. Hence, we have that 50 plus minus 3 marks for your trigonometry. You will be writing this during your June exam. Please take care of this topic. It is worth a lot. Right, now with trig equations, you need to determine the value or values of x if you are given this trig ratio now. Cos x is equal to minus sine 56,7, and then this x value lies between quadrant 0, from 0 to 360. That means the x value that you are calculating, it can be in any of the quadrants from 0 to 160 degrees. That is what this statement is telling us. Right, now we start by simplifying this right-hand side, put it into your calculator. You will be left with cos x equals to minus 0,84. A simplified minus sine 56.7 into your calculator is negative 0,84. Right, and remember, when you are solving the equations, we look at the reference angle. When you look at the reference angle, you take this cos to the side, it will be the arc cos of 0,84. Somebody may ask, what happened to that negative now? This negative is indicating the quadrants where cos is negative. Do you still remember those quadrants, grade 12? The cos is negative, it's our cast diagram. Cos is positive in these two, that means it's negative in second and the third quadrant. So our solution will be in those quadrants. That simply means this negative is telling us the quadrant of which we will be solving in. Okay, that is why we don't indicate it there. So when you look at the reference angle now, into your calculator is shift cos inverse, the arc cos of 0,8. That means this will give us a reference angle of 32,86. This is not yet our solution, is the reference angle. And then after finding the reference angle, now we move to the quadrants where we will be solving. We said we will be solving in quadrant 2 and the third quadrant. So with the second quadrant, we take our angle x, of which we are solving for x. What is the reduction in second quadrant? That is 180 minus. So we are going to use that reduction, 180 minus. Minus what? Your reference angle, 32,86. And then 180 minus 32,86 is giving us 147,14. That is the x value in quadrant 2. But we are not only solving in quadrant 2, we also solve in quadrant 3. Why? Because cos is negative in the second and the third quadrant. So our second solution will be x equal to reduction in quadrant 3 is 180 plus. Therefore, we will be using 180 plus reduction plus what? Reference angle 32,86 degrees. And then this is giving us how much, grade 12? 212,86 degrees. That is our angle in quadrant 3. You must also check your values, grade 12. 147, yes, is in quadrant 2. because it's before 108. And then 212, yes, it's in quadrant 3 because it's before 270. If you can get abnormal values that doesn't fall into, and that you must know you are going wrong. There is something wrong with your answers. Okay, so basically those are the values of X in those particular quadrants. And then let's look at the second activity there. You are determining the value or values of X if we are given our ratio is 3 tan X equal to minus 0,531. That is the equation given to us. We are still looking at the values in all quadrants. Okay, so for this one we have a challenge because we have a 3 there. Remember, it must be a trig ratio equals to something. In this case, you need to get rid of that 3. Now we are going to divide both sides by a 3. So now we'll be left with tan X on the left hand side. And then minus 0,531 divided by 3. That is giving us the minus 0,177. Okay, and then now we look at the reference angle. That is the method throughout grade 12. And then this will take an arctan shift tangent. And then remember, this negative indicates the quadrants. Ne? So here we write it as 0,177 positive. And then let's identify the quadrants now. In which quadrant is tangent negative? Go to your CAS diagram, it will help you. This is positive, all ratios are positive. Can you see now? We are solving in second and fourth quadrant where tan is negative. Right. Now let's check now. Shift tangent 0,177. What is our value in that? Arctan 0,11 is 10,04. Remember, this is a reference angle. It's not yet your solution. To find your solution, you must solve this in second quadrant. So in second quadrant, it's where we are having our X, of which is the angle we are solving. Second quadrant is reduction 180 minus. That means it will be 180 minus. Minus reference angle 10,04. And then this will give us 169,96. That is our angle in quadrant 2. This is in degrees Celsius. And then now we need to solve also in fourth quadrant because tangent is also negative in that quadrant. So in quadrant 4, which reduction is in there? That is 360 minus. So we are using that 360 minus reduction. It will be minus our reference angle 10,04. 360 minus 10,04, that is 349,96. That is in degrees greater. So this is our second angle. And then let's look at the mark allocation now. 1 mark will be for the method for simplifying the 3, dividing by 3 both sides for that one. The second mark for the identification of a reference angle or calculating a reference angle. The third mark will be solution in the first quadrant. In the second quadrant, the second mark will be the solution in the fourth quadrant. Hence, we have that 4 marks there, grade 12. So that is how you solve your trig equations. And then our last topic will be on 2D and 3D problem. 2D problems, we mean 2-dimensional problems. And then the 3D is the 3-dimensional problems. It can be a container, a cone, where we look at the volume, and if it's a container, remember it will have 3 dimensions. For example, if you have a box, you'll be having a length, the breadth, and the height of the box. Those are 3-dimensional. But if you have a square, it will be a side by side, which is a 2-dimensional problem. So now we are solving such problems. And then when we solve such problems, we target the 90 degrees triangles where you are going to use your Pythagoras, your trig ratios, and then we are going to use the sine rule, cosine rule, and the area rule to solve our problems, depending on the need of the problem. So here the diagram shows a crane PQ, that is PQR, that is a crane. and then is lifting a box from point M, from this point here, to point R there. So there is an item holded by that chain here from point M. And then PQ is PQ and MR are perpendicular to the ground. The one for PQ is indicated, this one is not indicated. So it's very important, Rachel, to go through your statement and identify any missing information that is not indicated on your diagram. So now this is perpendicular to the ground level MP, such that PQ RM lies on the same vertical plane. So T is the point, here is T, is a point on MR. And then PQ is 8, as indicated there. This is 8 craters. And then now PQR is 114. This angle here is 114 degrees. And then we have the 49 degrees there. And then they say this line is perpendicular to that one. We have perpendicular indication there. And then now, not perpendicular, sorry, the parallel lines, the RM is parallel to PQ. Is not given on the statement, but there are dashes on the diagram that are indicating that. All right, and then the first question here says that determine the length of PR. Determine the length of PR. Now we want the length of the PR, of which is the hypotenuse side to this angle here. And then the only thing that we have here is this hypotenuse side. Can you see, great terms? That means now we can calculate this angle here because of these parallel lines. We can have that angle here. Okay, how much is that angle? Angle MRP will be equal to angle QPR, of which is equals to 49 degrees. Why are they equal? Is because of the parallel lines. They are alternating angles between parallel line RM parallel to PQ. Hence, we end up with the 49 also here. Okay, and then from here now, we can calculate this side. So if I am standing at the angle that I'm having the value here, and then I am looking for this side here, what can we apply, great terms? What can we apply? Another way of finding this, even if you don't calculate that, great term, there is a shortcut to this one. Remember now we have sine rule, cosine rule. We have so many ways to do this. We'll also do that one later on. So we have the hypotenuse, not into the triangle. In triangle, let's concentrate in triangle RQP. We can even redraw the triangle to have a sense around this. And then we have Q there, we have P, we have R, and then we have 114 there, and then we have 49 degrees here, and then we have this side is 8 meters, and then we need to calculate that side here. So in this triangle QRM, can you see that? We have angle Q114, and then that angle down there, P is 49. So we can calculate that angle PRQ there, okay? PRQ. So in order to find angle PRQ, we are going to say 180 degrees, we minus 114, we minus 49. Why? Because of the sum of angles of a triangle. So now if we subtract the two angles, now we'll be left with 17 degrees. That means this smaller angle here is 17 degrees. Happy now we are having an angle 17 degrees now. So sine rule, remember now you must have an angle with the opposite side. The side opposite that angle must have a value. So now can we get that? Yes, we have 8, it goes with that 17 there. Can you see that? We have an angle and a side. And the angle that we want to calculate is having an angle. Happy, we can use a sine rule now. Right, we have identified the rule to use, we can use the sine rule. So what are we looking for? We are looking for PR. PR is opposite which angle? 114, that means it will be over sine 114. Equal to the other side that is having a value is side PQ, which is 8 meters. And then is opposite which angle? 17, that will be of sine 17 degrees. So now to find PR, we are going to cross this sine 114 to 8. When you cross that, it will be 8 sine cos multiply 114 degrees all over the sine of 17 degrees. Into your calculator, grade 12, straight to the answer. This will be 25 meters. The PR is equals to 25 meters. So that is the best way that you can use to find this particular side PR. Okay, moving on to the next question. And then remember now we are having 8 meters here, and then we have 17 degrees that we have calculated. We have just calculated that PR is 25. So as you are calculating, you put the information on the diagram, grade 12. We are still on the same diagram. We have parallel lines there. We have perpendicular there. And then they say now write down the size of RPM, the size of this angle here. Okay? Remember now you have a straight line here. Sum of angles on a straight line is equal to 180 degrees. That means angle RPM is equal to 180 from straight line. We subtract 90, we subtract 49 degrees. We will be left with how much, grade 12? That angle will be 41 degrees. So why are we saying this? Is because they are angles on the straight line. 41, that is 1.2. 1.3, complete the following ratio with respect to triangle RPM. We are taking this triangle here. Sine RPM, sine RPM, the sine of this angle here that we have just calculated, it's 41. The sine of that, because we are in 90 degrees triangle, we can use the ratio. A sine, remember, is so. That means it's then opposite over hypotenuse. Are we correct, grade 12? It's opposite over hypotenuse. That means now, this simply means sine of R angle RPM is equal to opposite. What is the opposite side? The opposite side is MR. Over hypotenuse. Hypotenuse side is what we have calculated earlier on as being the PR side. Ours is just to complete that ratio there. Hence, it's 1 mark for the first question and 1 mark for the second one. And then after the completion of that, grade 12, you need to apply that to answer other questions now. Remember, it's 90 degrees there, and there's 17 degrees there, is 41 degrees there. And then we have a sine of this is opposite, that is 25, we have just calculated before. And they say if TR is from here to here, that is 5 meters. And then determine MT. Now we want to find out the distance from here to there, the remaining one. So in the previous question, we have indicated that the sine of RPM is equal to what? The MR over the PR. And then what is RPM? That is sine of 41 degrees is equal to the MR. Do we have the value of MR? No, we have RT. That is 5. The whole of MR is this 5 here, plus the unknown of TM there. We don't know how much is TM. We leave it like that. It's when you add this piece, that one of which is 5 plus that one, they will give you the whole MR. And then the PR we have calculated previously is 25. And then now we are going to cross this because we need this TM here. We are going to cross, it will be 25 sine 41 degrees equal to 5 plus TM. And then transpose 5, it will be TM this side minus 5 plus 25 sine 41 degrees. And our answer for TM now will be equal to 11,40. Into your calculator, 11,40 meters. That is the distance TM. And then this is worth 3 marks. 1 mark will be for substitution there. The second mark for simplifying and having that minus 5 plus 25 sine 41. And the last one will be for the TM value 11,40 there. And then our next activity on 2D grade 12, that will be the last one with the following questions. And then in the diagram below, BDC is a straight line as indicated there. And then this is equal, BD is equal to DC, 7,44 centimeters there for each. And then angle B is 39,5, angle ADC is 74,5. Determine the size of the following. BAD. We are talking to that angle here. And then if you look at angle B plus angle BAD, that is equals to angle 74,5. Why? Because it's the exterior angle of a triangle. You need your geometry now, grade 12. And then what is B? 39,5 degrees plus BAD, sorry, that is 74,5 degrees. So therefore, angle BAD will be equal to 74,5 minus 39,5, of which is 35 degrees. It will be 24,99. Rounding off to the nearest degrees, it will be 35 degrees. That is the solution for number 1. It's easy, grade 12, they give it 1 mark because a learner can see that you need only to subtract this 39 from 75 to get the value for A. So I'm showing the whole step, but there's a short way of doing it on your calculator. And therefore now for BAD, we end up with 35 degrees for that angle. So now at 2.1.2, you need ADB, angle ADB. That means this angle here, of which is next to that 74,5. Since they are on the straight line, that angle ADB, it will be equal to 180 from a straight line, and then you subtract 74,5 because of angles on a straight line. And then this will give us how much now? That is 105,5 degrees. That is the value of ADB here. Okay, now we have calculated the angles. Let's see how far can we go with the question. Can you see the repetition now? You need to fill in the missing information there. Complete the following with respect to triangle ABD. We are looking in triangle ABD. That means we are looking to this triangle here. And then the same sign ABD is this angle here. So it goes with this side AD. So it will be AD over side BAD. And then the BD side is this side here. It will go with this angle here. That means it will go with side of angle BAD. So now we have completed that. It's 1 mark. They say hence determine the length of AB. Hence determine the length of AB for that one. Let's see, grade 12. Okay, complete the following with respect to, okay, this was supposed to be BDA, not BAD. BDA, angle BDA, the sign of angle BDA, and then on top there it will be AB over sine BDA. Okay, let's check again. BDA, it goes with side AB, correctly? And then now followed by BD. BD is correct, it goes with BAD there. As you can see, that side goes with that angle there. Okay, sorry for that mistake, grade 12. And then it says, hence calculate the length of AB. So if we calculate AB, we'll take the same fraction that we've indicated, or the sign rule that we indicated on top. AB over sine BDA, and BDA is equal to BD over sine BAD there. Now we substitute. Do we have a value for AB? No, we don't have that one. We are looking for that AB, and then we have a sine of BDA. BDA we have calculated on the previous question that the BDA is 105.5 degrees, and then the BD we have also calculated the length of BD is given to us as being 7.44, and the sine of BAD. BAD is the angle on top there that you have calculated as 35, that will be sine of 35 degrees. And then you cross. Can you see, most of the time you'll be cross multiplying 7.44 sine 105.5 degrees over sine 35 degrees. Into your calculator, it will give you the AB value being 12.5 centimeters. That is the value of your AB. Lastly, grade 12, that is the last two questions. Hence, determine the length of AC. We know now this side is 12.5. And then we have 35 there, calculated from the previous questions, 39.5. Here we have 105.5. And we have 74.7, yes. And then determine the length of AC. AC, we are talking to this side here. And then in order to find AC, grade 12, and you see that you have AC in this triangle A, B, C, the bigger triangle, right? AC is opposite 39.5. Or do we need to redraw that? I hope you see that. This is opposite in the bigger triangle. We are referring to this triangle A, B, C here. The opposite angle to side AC is 39.5. And then now you need to target the other two sides that are including this angle here. That means it's 12.5, and the length of this whole side here is 7.44 plus 7.44, which is 14.88 for the whole length up to here. Right. Do we have all what you need? Yes, because now this is telling us we need to use a cosine rule. Cosine rule says they take the side that you need to calculate of, which is AC squared, and the square of the other two sides, that is AB squared plus the BC squared, minus 2 times those two sides, that is 2AB BC, and the cos of the angle opposite to the side you want to calculate, that is angle B there. Okay, and then now we want to calculate AC. This side will use the exponent 2, this will gain the square root. I'm automatically doing that with substitution. AB 12.5, this must be squared. BC 14.88, of which is 7.44 plus 7.44 squared, minus 2. We are now substituting the same value of AB 12.5. Remember, these ones are no more squared now. BC 14.88, and then the cos of angle B. Angle B is 39.5 degrees. Into your calculator, grade 12, straight to the answer. It is giving us 9.52 centimeters. That will be the length for AC. Lastly, 2.4, determine the area. Remember, the area of a triangle ABC, you must have two sides and include that angle. We can also use that one. because we are looking at the triangle of ABC, of the bigger triangle. We take the sides to the bigger triangle, 2 sides and an included angle. That will be half of 2 sides. Which sides are we referring to? AB and side BC. And then it must be a sine now, not a cos, a sine of included angle, 39.5 degrees, because we are calculating the area. And then now let's substitute AB, 12.5, BC, 14.88, and then the sine of 39.5. Into your calculator, straight to the answer, grade 12. The area of this is 59.16, because it's in centimeters, it will be square centimeters. That is the area of that particular triangle. And then grade 12, this brings us to the end of today's session. This lesson was brought to you by Gauteng Department of Education with collaboration with Cyborg Discovery Center. See you next time. Thank you. Bye.